All right, hello everyone. Thank you for this great opportunity to speak to the Apache Flink community and to the sponsor of this conference. Obviously, thank you to everyone for adapting and making this important information available virtually. It would have been a lot of fun in person, but here we are. So Cloudera and Hortonworks have both been longtime strong believers in the power of open source and also the stream processing space in particular. Cloudera today has many customers taking advantage of stream processing in various forms, perhaps with our most history, or the most history that we have perhaps being with Apache Storm itself, actually, for those of you familiar. For quite a long time, for several years, even back to the Apache Stratosphere days, we had our eyes on Apache Flink, and we're always very fond of the community, how it was forming, the way it conducted itself. Flink's a great example of a community where despite various vendors, large customer users, it's remained a good example of both open source and open community done very well. So kudos to all of you who've been a part of Flink for so long to see it and help it reach this point and for doing things the right way. I was very excited last year when about this time we were able to successfully make the case at Cloudera that it was time for us to invest in Flink and the community, and that we had a great opportunity to launch with seasoned Flink veterans and engineers who are both true believers in stream processing, but also understand our larger data and motion vision. Today, I'm quite fortunate to share briefly with you a bit about Cloudera Dataflow and how Flink fits so naturally into our story to really complete the processing aspect of what we're doing. So our data and motion philosophy really is rooted in the complementary power of the three domains in which Apache NiFi, Apache Kafka, and Apache Flink operate. NiFi and its related projects, including Cloudera's Edge Management, focus on the domain of data flow management. Right? So this is about collection, distribution, and transformation of data broadly. NiFi in particular concerns itself with the size and shape and format and schema, the interest between systems sharing data. What data are they interested in particular? How are things authorized? What protocols are optimized for a given producer or given consumer? It's effectively then a broker between systems that frankly never knew to plan for each other. This is a need which only becomes more and more important as an enterprise grows. And as various architectural modernization activities occur. Things like mergers and acquisitions occur, bringing in new systems, new complexity. Data is often exchanged between different business units or commercial partners, and so on. Fundamentally, data is often generated several hops removed from a downstream consumer that may have entirely different needs. This space is really the role of data flow management, and that's what NiFi and its related pieces focus on. Kafka then, and its related components, such as Kafka Connect, Kafka Streams, things like Cloudera's Streams Messaging Manager and Streams Replication, support the Streams messaging domain broadly. This serves as a powerful substrate for streaming first producers and consumers to share data of a particular format and schema on agreed upon topics of exchange. That protocol of exchange is fixed to Kafka's client protocol or bridged with Kafka Connect instances or data flows in tools like NiFi. The format and schema of data is specified and understood for a given topic so that all consumers can focus on their business logic. The fundamental logic then of how streams of events are exchanged between producers and consumers is held within the producers and consumers. This is in contrast then to the model I just talked about with NiFi, where it's effectively acting as an active broker between producers and consumers. Kafka is then acting as a passive broker between producers and consumers. This model that Kafka offers then is really optimized for both ad hoc and sustained stream message exchange. It then is an ideal buffer between systems that gather data like Apache NiFi and systems which turn it into insights like Apache Flink. Flink then supports the stream processing space, broadly speaking. Now, Flink offers powerful data processing semantics generally, but it has particularly interesting, or has made particularly interesting progress for stream processing. As folks attending the Flink Forward conference, you know this quite well. Marton will go into this a bit more soon as well. At Cloudera, we're providing the enterprise data cloud. At the heart of this, then, naturally, is the connected data lifecycle. From a traditional data at rest or batch processing point of view, there's this broad initial phase called data collection or ingest. This is usually followed by a data engineering or creation phase, where data is enriched, cleansed, touched by magicians, and so on. Typically, this is followed by a data warehousing or reporting phase where data is aggregated and counted, usually then followed by some sort of an operational database, which serves this information typically for a fairly well understood set of consumers asking a fairly well understood set of questions. Finally, and perhaps a more recent development, but there's a machine learning and or AI phase that's run against this data to establish models of expectation and measure the latest data sets against that. Increasingly, though, as we all know here at this conference, customers and users of data at the enterprise scale want their data, their insights, and their ability to take action to be fast. Effectively, they want it to be immediate. For this, we bring into focus our approach to data in motion. The collection and ingest phase remains largely the same. It's frankly always been streaming in nature. It's often followed by stream messaging or buffering. This doesn't mean the data has to be consumed only once it's buffered, but rather that both batch and streaming oriented consumers can operate on the data in near real time, or frankly, as fresh as the data is made available. It does mean that the buffer or stream contains data of a relatively known quality, format, and schema, which is extremely advantageous for downstream processing, as it can spend less of its time on that and more focus on actual processing of the data. This is usually followed by either a distribution phase or a data processing phase, which are inherently stream-oriented. And finally, there's an action phase. At this point, maybe some system API may be actuated or some other steps taken. Done well, this forms a sort of closed loop. Perhaps most importantly, though, it's not that we have a data at rest pipeline that we talk about or a data in motion pipeline that we talk about, but rather what these things can do in their natural interconnected state. Data engineering benefits from data in a stream first delivery mode, obviously, as they can start to reduce their own latencies. They can provide more powerful processing that can then, of course, enrich the data in the buffers itself. Similarly, the distribution phase can enrich data as it streams by against data sets pulled from the data warehouse. This can obviously be very valuable for downstream processing consumption as well. Stateful data analysis with access to rich operational database information is, of course, far more powerful, far more contextual, allows you to take smarter actions as a result. And scoring live events against models while also feeding the new evolutions of that model is a clearly far more powerful model than nightly execution against last night's run or last night's model. Cloudera's connected data lifecycle then supports all of this. And it does it in an integrated fashion from collection through prediction. Really at the heart of this is enabling enterprise IT to do better than the shadow IT that sort of crops up throughout an enterprise. And ultimately, for the enterprise to drive insights from data both faster and at higher scale than they would have been able to do before. This is fundamentally what we call the enterprise data cloud. So putting our data in motion components into a little bit more context. To do so, we've put together a little bit of admittedly trivialized high-level architecture here, but for one of our common cases or one of our many cases, here we have an airline with kiosks at various airports in the world. In the kiosks at the airports, data is collected using Minify. It is then prioritized as there's multiple data sets, data campaigns that may be running at the same time. Some data is more time tolerant, some is more time sensitive. The bandwidth is extremely limited. And so this data needs to be constantly prioritized as buffers are occurring. New data has to be reprioritized, or the highest priority data needs to get through, but still the latency, or sorry, the bandwidth constraints need to be managed. All that data is then sent centrally to either a data center or one of the cloud providers. At that central point, then, data is enriched and transformed into the formats and schemas that are supported by downstream consumers, in this case, Flink. So Kafka then provides that buffer. Flink pulls from Kafka to provide streaming analytics on that data, or stream processing on the data. But it's also important to note that another sort of powerful aspect of this is that because the data is made available in these well understood Kafka topics, because things like the format and schema then can be well published and understood, it allows for ad hoc consumption, which supports new and emerging use cases that may not have even been understood at the original time of establishment. Important to note here, though, is this very same, admittedly fairly simple architecture and general pattern applies over and over across many use cases and industries that we deal with. Sampling of these include things like medical records collection and processing, oil and gas, machine and sensor data, tech ops across, frankly, every industry, global transaction resolution for like global financial institutions, financial institutions that may do things like marketing campaign effectiveness, tracking and monitoring, cybersecurity, both active and passive log collection and processing, predictive maintenance for steel manufacturer, connected car for auto manufacturer. Ultimately, this is all set. This whole notion of Cloudera data flow is focused well beyond the components, though, of just NiFi, Kafka, and Flink. It's really about providing an enterprise-grade platform to make these consumable and consumable together very effective. So in the case of our flow management, we have flow development lifecycle capabilities that are integrated. We offer Cloudera Edge Manager to control the first mile collection challenge that Minify deals with. Cloudera's schema registry ensures that anything in the flow, anything in the streams or the stream applications themselves can all be reasoned over in a consistent manner, which allows evolution of the data on defined bounds. And streams messaging ensures that the health of Kafka, the nature and production of consumption of data can be well understood by operations and business users. Streams replication solves for things like geo-replication, disaster recovery. And then this underpinning shared data experience supports major components of things like governance and deployment and so on. So in particular, worth calling out, and Martin will do or talk about this a little bit more as well, but all of our flow and stream processing components are all designed to generate and make available really fine-grained lineage information that makes it extremely easy to track in a truly end-to-end way how data is collected, distributed, transformed, where it's sent, and so on, which is really powerful for a number of reasons, compliance being just one of them. And of course, as I mentioned, deployment and single sign-on is a factor, but also authorization and auditing, also powered by things like Apache Ranger. In just a moment, I'll hand off to Martin, who's going to dive further and more specifically into Flink and its fit and function within Cloudera Dataflow. But first, let me take a brief moment to explain Cloudera's data in motion journey, or to put it in context. When we first launched our data in motion product, it was really focused on that sort of initial codeless data lake ingest space. This visual drag and drop style of controlling ingest is quite helpful, very powerful for our customers, but quite obviously, an ingestion focus doesn't solve the first mile problem that really exists for most use cases, and frankly, for most streaming use cases. You fundamentally can't just sit and wait for data to show up or hope that it will arrive via convenient always-on streaming protocol. While quite often the nature of data you want to analyze is inherently streaming first, we tend to have systems that screw that up along the way. So we've introduced Minify to help with that first mile collection. And we've also seen a strong growth in the number of and geographic distribution of NiFi clusters to distribute this data at various points in the enterprise, be it regional office, data centers, between cloud environments, and so on. But this did leave at the same time, we also saw a really strong uptick in the number of Kafka clusters, similar to the growth of NiFi clusters. And basically every flow ends up putting data into various batch systems like HDFS, traditional databases, but also basically every flow ends up in Kafka. This largely reflects, I think, the growing desire to do true stream processing that systems like Flink make possible. But this did leave an important gap in our solution space. We've had Spark in the broader portfolio for a long time, and certainly this is an extremely important workload. But we also saw an increasing need and demand for true low latency, but high power stream processing, which is when we were able to bring Flink into our data in motion portfolio in particular. Where we are today then is bringing these things together in a combined fashion for flow management, stream messaging, and stream processing in a nicely integrated manner, both at the data center, in the cloud, with our edge management solutions, and through our CDP data center and data hub offerings. Data hub running in this case both on Azure and Amazon Web Services. So now it's easier than ever for our customers to build well-integrated flows and stream applications across these deployment environments. But truth be told, we're not even close to finished with this vision. Where that box is showing you is basically where we are today. But where we and our customers are going is driving towards a model of a higher level consumption abstraction and deployment model. For that, we're closing in on the Cloudera data platform data flow service. We'll talk about that a bit more here later in this talk, but we'll go into more detail at a later time. For now, I'd like to pass over to Marton, who will dive deeper and more specifically into our Flink efforts at Cloudera. Thank you.
Thank you, Joe. So basically, the first step that I would like to show you is enabling Flink to be able to widely use within the enterprise. And I would like to start with a slide that we actually showed to Flink Forward Berlin half a year ago to be fully transparent on what we thought 6 months ago was crucial to this community and how much of that we actually managed to deliver. And I'm happy to report that we have done the majority of what we have promised on this slide. We are in different stages of contributing those implementations back to the community, but we certainly prioritize that all of this makes it back to Apache Flink or as much as it's possible. So in terms of the platform integration, that obviously means that all of the Cloudera tools need to implement a unified security model. They have to deploy in the same way and so on. And we have done all of the basic ticks in that box. When it comes to enterprise security, when we open that up, Joe has already mentioned Apache Atlas as our lineage and metadata management tool. We are delivering integration for that as in our upcoming release that is coming in May. And shortly after, we'll follow up with Apache Knox. In terms of our connectors, we have revamped the HBase and Kudu connectors. We have already opened the pull request to contribute the Kudu one back. And we have implemented a connector for our version of the schema registry. All of these make it possible to form the foundation of how Flink fits into the broader Cloudera picture, which obviously we focus on NiFi, Kafka, and Flink as our central story, as Joe has outlined. But these other pieces of integration have to be in place so that we form this foundation and we get to build on towards the more exciting use cases. We were mostly focused on these in terms of implementation, but we also want to highlight that our scope in terms of Cloudera for the Flink community, we believe that we should be able to provide regular content in terms of blog posts, or we are launching a podcast series around Flink, being here for the community at conferences, and not just at the keynote. We have multiple talks by the engineering team scheduled later during the upcoming days. This is all that we are contributing to the community, and we are happy to keep this up and collaborate with you as much as possible. So let's dive deeper into the enterprise functionality that we are adding, specifically the Atlas integration. Atlas is a lineage tool, and often what you would have in mind when opening up an Atlas UI is that you have a topic in mind, using the same use case that Joe has already mentioned about airlines and their kiosks at airport. You might have this kiosk alert topic at hand, and you would like to be able to understand how this alerts topic is actually created, what are the steps that were taken to be able to produce the records that you are observing in it. And Atlas will show you that, well, the only producer to this topic happens to be a Flink application by the name of kiosk errors over the last 10 minutes. And you can also inspect that there were 2 Kafka topics feeding into that, and there happened to be an i5 processor that fed those Kafka topics. So this is obviously important in a large enterprise to be able to understand how the data is governed and how the data is created throughout the enterprise. But it's also important in regulatory compliance cases. We have a number of customers where they are required to be able to produce these records for each application or each data set that they curate. Once we have closed most of the foundation pieces, and as I said, we are through with the majority of these tasks, fortunately, and we get to focus on the next pieces of interesting additions. Throughout talking to our beta customers, as we have launched our generally available product early on this year in January, and prior to that, between Flink Forward Berlin and January, we were running a beta program. And one of the overwhelming feedbacks that we received was that although these customers, Flink users, really enjoyed the rich features that Flink can actually provide to them and the APIs that Flink provides, they had that first mile problem, understanding how the concepts work, finding their way to the UI or to a new job, or finding the metrics. And these simple things, connecting them and enabling them as fast as possible, this was a concern. So this might seem minor to you, but for example, we have enhanced the Yarn history server functionality to also include the running jobs going forward. This is also coming in our May release, which makes the history server, which perfectly fits with the Yarn model. So you would see the same for Spark as well, in terms of just having a history server, and then you would need to go to the Yarn Resource Manager UI and find all of the running applications. That is a model that works, but it is certainly clunky and a little bit tedious. With this improvement, now the Flink dashboard or global dashboard can give you a single pane of glass when it comes to Flink jobs. And we find that this actually helps onboard customers significantly, even though it is seemingly a small change. In terms of additional content and easing that first mile problem into Flink and being able to get value out of Flink as fast as possible, we have delivered on the blog post promise. We have started writing technical blog posts and business related blog posts around Flink as well. The first couple of blog posts were centered around log aggregation on Yarn, with being specific to Flink, because that was also a feedback from the beta program that since these applications are long running, the legacy log aggregation solutions weren't a great fit. So we have written these pieces of information so that our customers can get up to speed faster. As I have mentioned, we have also launched a podcast series called Power Chat series around Flink. We already have the first episode last week. We are planning to run these monthly, so please join our second edition in a couple of weeks. We also have a tutorials maintained on GitHub under the Cloudera handle. These range from simple quick starts to production-ready applications to a security tutorial that gives you all of the bits and pieces when it comes to a Kerberos and TLS-enabled cluster. With our upcoming release, we are also adding a SQL tutorial to this mix. And obviously, as we have a GA offering based on Flink, we have an online documentation, and we are also representing Flink and positioning Flink when it comes to our conversations with industry analysts. In terms of the developer experience, the next really exciting point and what we think gives the uniqueness to our Flink positioning is obviously we place NiFi, Kafka, and Flink together in the middle of this philosophy, and this is how we think about these tools in unison. And I've already outlined how Atlas augments that message. The other portion on the top of the slide is how schema management is necessary for this end-to-end solution to work very well together. So since NiFi is schema aware, it can already expose this schema to a centralized schema registry, which we do offer, so that when Flink picks up a Kafka topic, the Flink doesn't have to, the schema doesn't have to be baked into the Flink topic anymore via this integration. So if the schema were to evolve, which the schema registry fully supports, then Flink can keep on processing the records if it was and the Flink job was written properly. We think that this is really powerful for production systems, and it also happens to enable ad hoc queries really nicely too. So let me give you an example for that. So let's say we would like to compute the number of errors per host in our previous use case for each 10-minute window. So we have a Kafka topic called Kiosk Events Row San Francisco. You can see the schema registry UI on the right-hand side of this slide. There we get to inspect the schema as well. And based on this, similarly to what you have seen from Stefan's keynote previously, we get to add, in terms of the SQL integration, we get to add a catalog on top of the schema registry as well. This is also an addition that we are shipping in our next release. And this means that you don't have to create these tables in SQL anymore, because we can implicitly create them since NiFi has already provided the schema for them. And this makes it really simple to understand how the data looks like and write simple aggregations like the one we are presenting here directly on top of these queries without finding out what the actual schema is and having to jump through hoops to be able to do so. So far, all of the pieces that I have been presenting, the foundation piece, the developer experience piece, plus the SQL piece, those are all either already shipped in our January release, or we are shipping them in our May release. Now, I would like to follow up on Joe's promise and show you where we are going in stage 6, so to say. So these are the tasks that, for our midterm vision, and we are certainly working on those. We would like to share this with the community to see whether you also get excited about this way of interacting with these systems, and looking for your feedback. So in terms of deriving business value, and that's ultimately why these systems are deployed, the way to think about them, or the basic concept that our customers usually understand, is how to implement a data pipeline that derives that business value. So ultimately, that's what we have to think about. And that data pipeline can be mapped to NiFi flows that feed into Kafka topics that Flink stream apps can pick up. And we believe that this is the level of abstraction where most of the customer's time should be spent on. Whereas we have experienced it in many cases with our customers that unfortunately this is not where most of their time is spent on. Most of their time is spent on deploying applications, deploying clusters, managing configuration, tweaking applications, rebalancing them, scaling them up and down, and so on. We believe that this is where a customer should be focused on, and we believe that we can take ownership and automatically do most of the rest. So how would the user experience look like in such a solution? But where are we heading? So let's say we have already used NiFi to create this kiosks events row San Francisco topic, which is the topic on the top. We also want to bring in the Streams Messaging Manager functionality to be able to understand the producers and consumers to this topic and see basic metrics on it. So let's shoot for the most interesting use case and create a Flink SQL, a Stream SQL query on top of this. So let's use the previous example and let's create an environment on AWS. Obviously, we would like this to be a streaming query and use a Kafka endpoint in kiosk alerts to produce to. There is a little bit of sizing and scaling information that the customer needs to provide, but we can pretty much figure out the rest. And then let's provide a SQL query editor when the customer gets to plug this in, where it's really important to highlight that we also provide the schema information then for the customer. Hence, that was already populated by NiFi and is stored in the schema registry. So it's really simple to iterate on that experience that I just outlined when I talked about SQL. Obviously, the customer needs to have some type of interaction where they can test their SQL query, have a simple Kafka consumer that lets them do that. So let's exactly do that. Let's have a couple of records pop up. Then we are sure that this is a query that we actually want to deploy to the cluster. So let's go ahead and deploy that. Once we are through that, we should be taken to an applications page where we get to inspect these applications. So to summarize, the way we are thinking about Flink and positioning it, we need to start with a foundation, and we are mostly through that, integrating the deployment schema and lineage story, unifying the security model. Then the two main topics that we are bringing on right now and doing most of the implementation for and making it available in May are the development and the Stream SQL stories. And we have also outlined our vision where we would like our users to focus on flows, topics, and stream apps. With that, I would like to thank you for listening to our keynote, and we are more than happy to hear your feedback one way or another.